Hello, everyone, and welcome to video 3 in this series. This time we're going to be looking at skill number 3, trigonometric ratios. And trigonometric ratios are kind of the foundation of everything else we do for the rest of the unit. And this is where you'll see why we spent so much time going over opposite, adjacent, and hypotenuse sides. So the ratios of the sides of a right triangle are called trigonometric ratios. And these ratios are super useful for solving problems, not just in geometry, but in pre-calculus and calculus and further down the line. There are 3 main trigonometric ratios: sine, cosine, and tangent. And I've got the full words written out here, but in general, you'll see them with the 3-letter abbreviations, including on the calculator: sine, S-I-N, cosine, C-O-S, tangent, T-A-N. Each of these is defined as one side of a triangle divided by another side. So sine is equal to the opposite side of a triangle. I'm just going to abbreviate this op divided by the hypotenuse. I would actually, you know what, maybe I'm not going to abbreviate it that way. I'm going to write it out. Opposite divided by hypotenuse. And we just put a line in there to show that it is divided. Cosine is equal to the adjacent side divided by, again, the hypotenuse. And again, this line in the middle means divide. So cosine is always equal to the adjacent side divided by the hypotenuse. And finally, tangent is equal to the opposite side divided by the adjacent. Now, you might end up memorizing these, but you don't need to memorize them. However, you absolutely need to be able to figure out, if I say tangent, you need to know that's opposite divided by adjacent. And so if you need to have these notes on you, that's fine, but make sure you have the notes around for the rest of this unit so you can always look this up because it's super important. All right, now we're going to go through and actually use these trigonometric ratios to work with a triangle. So below we see a triangle. We see an angle theta. Remember, that's the Greek letter theta, and 3 sides. Just to make it easier for ourselves, we're going to label the sides right away. So the hypotenuse, of course, is the longest side. In this case, it's 10 centimeters. Opposite, remember that changes based on the triangle, but in this case, the opposite side is opposite angle theta. So it's going to be over here. This is going to be the opposite side. And then the adjacent, the remaining side, the side next to the angle that's not the hypotenuse. So we've got the hypotenuse, opposite, and adjacent sides. Now we just need to define these ratios. So we remember that sine, if we look up here, is opposite divided by hypotenuse. So what is the opposite side? In this case, it's 6. So it's going to be 6 divided by the hypotenuse, which is 10. 10. So all I did was I took these numbers from the triangle and moved them over here. Opposite divided by hypotenuse, 6 divided by 10. Then you can plug that into a calculator and you'll get 0.6. So the sine of angle theta is 0.6. Now we'll do it with cosine. Remember, cosine is adjacent divided by hypotenuse. So the adjacent side down here, 8 centimeters. The hypotenuse still 10, so 8 divided by 10. Sometimes you'll want to write it as fractions, other times you'll want it as a decimal. So of course you can just do 8 divided by 10 in your calculator to get the decimal, 0.8. And finally, we'll do it with the tangent. Remember, tangent, opposite divided by adjacent. So we've got the opposite side, 6 centimeters, the adjacent side, 8 centimeters. We're going to do 6 divided by 8. And you can put that into your calculator to get a decimal. You'll get 0.75. So that's just a quick introduction to trigonometric ratios. We'll go ahead and do one more example. Pause here if you need to get these notes written down. Super important you know what each of these functions is, and that also you have the examples down. All right, let's look at the next slide. So I'm going to start off by labeling the sides again. In this case, it's asking for sine of A. So we have to find angle A. Angle A is right here. The hypotenuse, always the same, the longest side. In this case, it's 13. The opposite, opposite angle A down here is 12. So this is the opposite side. And I'm going to actually add opposite A. So we remember it's not opposite B, it's opposite A. Then adjacent to A, in this case, is 5 feet. Okay, so we've got our sides labeled. Now we remember sine is equal to opposite divided by hypotenuse. Some people just like to abbreviate O divided by H. So what is the opposite side? 12. What is the hypotenuse? 13. We'll just do 12 divided by 13. And I'm going to have to grab a calculator. Good thing I'm still in my classroom. 12 divided by 13 can round to a couple decimal places, 0.923. I would recommend when doing trigonometric ratios, use at least 3 decimal places. All right, now we'll do cosine. Cosine, remember, is adjacent, A divided by hypotenuse. Adjacent in this case is 5. Hypotenuse is 13. Again, I'm getting these just from the picture over here. 5 divided by 13 equals 0.3846. I'll round that to 0.385. And finally, tangent. Tangent is opposite divided by adjacent. Again, you do not need to memorize these. You do need to know them, which means you need to always have these notes handy whenever we're in this unit. So opposite side is 12. Adjacent side is 5. 12 divided by 5. This one I think I can do in my head. It should be 2.4, but I will check that on the calculator. It is in fact 2.4. Okay, now we're going to look at the sine, cosine, and tangent of angle B. And this is where it's going to get a little tricky because we already labeled the side here. But now we're looking at angle B. So I'll use a different color. Here's angle B. Now this side that used to be the adjacent to A is opposite angle B. So I'm going to make a note that this is opposite B. And this is why it's so important to know your opposites and adjacents. And this is adjacent to B. So this is the opposite. This is the adjacent. Now that we're looking at angle B, we care about what's opposite B and adjacent to B. Of course, the hypotenuse stays the same. So sine is opposite divided by hypotenuse. Now the opposite side is here. It's 5 feet. So it's 5 divided by 13, which is the hypotenuse. We already did 5 divided by 13. We got 0.385. Now cosine, adjacent divided by hypotenuse. The new adjacent side, adjacent to angle B, because this is asking for the cosine of B, is 12. 12 divided by 13. Again, this is something we've already done. 12 divided by 13 divided by is 0.923. And finally, tangent is going to be opposite divided by adjacent. The opposite and adjacent have switched spots. So instead of 12 divided by 5, it's now 5 divided by 12. This one we have not done before. So I've got my calculator. 5 divided by 12. 0.41667. We'll round it to 0.417. Okay, so there you have 6 more examples. This one's tricky because some of them are looking at angle B and some of them are looking at angle A. It depends on the angle. You might notice that sine and cosine switched, which makes sense because angle A, the opposite is 12. For angle B, 12 is the adjacent. So sine and cosine switch when you switch the angle that you're looking at. Tangent just kind of changes. All right, I hope this is helpful. Make sure you have these notes written down. If you have any questions, you can rewatch the video, you can pause, you can slow it down, and of course you can ask me and your classmates for help. Now that you're done with this, you can grab 6.3 practice, which is over in the bin over there, although you cannot see it in this video, and have a good one. Bye-bye.